please either raise your hand so I can see that, or just type it into the chat box. If there's a particular question number or question type that you'd like to see, that's perfect. You can, like I said, if you want to talk, just raise your hand first, or just type it into the chat. I have both things open so I can see if you have any questions. So I'm going to switch my sharing. And the first thing I want to point you guys to is the dosage calc blueprint. A lot of times students will ask me questions like rounding rules and, do we need to do this, that, or the other thing? The blueprint tells you specifically what you're responsible for, as well as what types of questions you're going to see on your test. So this is you guys with Nursing 130. So you can see you're going to have a very similar test that you had last semester for 110. The big difference is you're taking it next week. So you don't, this is your prep time. You're expected to already know how to do most of these things, but the questions are going to be very similar. The fact that you're in 130 tells me that you passed the 110 test. So this should just be a review for the most part, but like most nursing students, math is not on your forefront. You have a whole bunch of other things that you're trying to kind of land and understand and master. So I understand that. The thing that's going to be a little bit different for you guys this semester than last semester is the what was it? I think you're doing some flow rate questions. Just give me 1 second. Yeah, this is new. So what are considered your flow rate questions, where you're going to actually calculate milliliters per hour, drops per minute. And so we'll go over those. All right. So that's the blueprint. This is also listed in the OneDrive folder. So if you ever need it as reference, but it should also be in your nursing packet that you received either digitally or printed off, or both. But just so you know, whenever I reference rounding rules and things like that, that is where this is coming from. And I'm going to try and be very explicit with the rounding rules and try and give you some better direction than maybe I've been in the past. Okay. Okay. So your review is going to look similar to this. So what I did is I actually rephrased a lot of the wording for basically what you're going to find in the blueprint. And then that's how I came up and put together these practice sets back in 2016. So over 8 years ago, we've been following the same blueprint. It's just so you know. All right. So some things you need to know prior, just like you needed to know in 110, because it will not be given to you. You need to know your conversions. As always, that will not be given to you. If last semester you missed a conversion question, make sure you're practicing those. If you missed, marking, your cup or your Tubex or your syringe, make sure you practice that. If I'm not mistaken, your test is going to be paper, but it could also be on Blackboard. I do not know that. So I know that someone's going to come in and ask that question. And I'm going to tell you right now, I do not know that. So I guess I should have asked, can you guys hear me? Can I get like a thumbs up or just chat in the box? Like, I hear you. Just want to make sure. Okay, good. I think someone would have said, is he talking? So, okay, thank you. Okay, perfect. Thank you, everybody. Okay. All right. So rounding rules, where things get a little bit kind of sketchy or troubling is you probably know that you should round. You just don't know if there are exceptions to rounding. So the main rules of rounding are, if you have a number greater than 1, you round to the nearest 10th. If you have a number less than 1, you round to the nearest 100th. Okay. So like, let's say I have an example of let's say this was 0.25. You would leave that answer as 0.25. But if you had 1.25, then you would round that to 1.3 per the rounding rules. Okay. The exception to that is if I'm moving from grams to, or milligrams to grams, or micrograms to milligrams, and let's say I go from 250 to 0.25, that's your answer. But that makes sense. You're like, okay, well, that's not a big deal. But if you have, let's say, 1,250, then your answer would be 1.25, and you would leave that alone. Okay. You do not round basic unit to unit or metric to metric conversions. And I'm going to give you some examples of that. You do round when you're going and making a conversion from the metric system to the US standard or vice versa. So the best example of that is when you go from pounds to kilograms, you're going to need to round most likely, especially if a number that is like 76.45454545 repeating. You do want to round those numbers, and I'll give you examples as well. And then, yeah, so I'll just give you some examples here as we move along. So, all right. So I'm going to move through. There's some helpful equations. We'll talk about those. You'll see me use those, but let's get into the meat of this. All right. So one of the things I always do, and this is going to frustrate you, but I'm letting you know that before we kind of get started here, I'm going to change these numbers. The key is not going to be accurate for this as we go along. So I'm just letting you know that. I'm just going to go ahead and just, I'm just going to mark this all out just preemptively. That way, you know, if you come back to this, you'll know like, oh, okay, this is no longer accurate, because I'm trying to use this as a review session to give you options. The original practice set should be good to go, and you can see it. It's available on the OneDrive folder, either as a Word document or as a PDF. You can print it. Even if you've done the questions 100 times, do it 10 more times, because the repetition of how you do the problems is really what it comes down to. It's not necessarily having different examples all the time. All right, so let's look at these first 4 questions. And you might be saying, well, where did these first 4 questions, like, why are we talking about these 4 specifically? So on the blueprint, it tells you that you're going to have 2 household measurement questions, converting between systems, the metric and household, as well as 3 metric unit conversions. Like, it says kilograms to grams, but we never do that. It also says pounds to kilograms, which is technically a household to metric or metric to household conversion, but that's okay. Basically, the first 5 questions are just conversion questions. Now, before you start any of these, you need to know, like, when we're going from milligrams to grams, or you're going from grams to milligrams, whatever your answer is, you do not round that answer, okay? Leave your answer as is, unrounded. So any metric. But if you're going from metric to household standard to metric, or household standard to metric, then you may need to round, because you're going into different units. Okay. May not always need to round, but I'm just giving you some examples. So what I'm going to do is I'm actually going to change this up a little bit. I'm going to make this actually be, I'm just going to change this up to just a different number. So let's just make it 37. This one will make it to be, what's to say, 1,052. And then we'll change these up as well. I like to give you different examples, even though yours will probably be like very, very kind of not like odd numbers like this. It'll probably be very straightforward, but I like to give you some options. And then this one, I'm actually just going to do 1 1/4. Okay, so let's look at these questions individually. I'm going to group these so that I can show you and give me some space here to work through these. It's always a good idea to start with these, even though they're quote unquote the simple ones. It's good just to review. So first and foremost, hopefully you remember that 1 gram is equal to 1,000 milligrams. Okay. You need to know that. Nobody's going to tell you that. And I'm just letting you know that in case you were thinking you can get off from it. If you're going to do this, what I call the easy way, which is you already know that there's 1,000 is 3. I'm going from a smaller unit to a bigger unit. And give me 1 second. Sorry, this is giving me things. Okay. If you're going from a bigger unit to a smaller unit, then it's going to, the number's going to get smaller if you want to look at it that way. Or when I know that I'm going from milligrams to grams, I know I'm going to move my decimal 3 places. The biggest thing is, which way am I going to go? So right now I have a decimal right there. Okay. At 37, there's a decimal. So if you ever get stuck and you're wondering like, well, how do I know which way to move my decimal if that's the approach I decide to take? Well, if you know that 1 gram is 1,000 milligrams, then you know your answer is not going to be 37,000 milligrams, right? Because you know that 1 gram is 1,000 milligrams. So you're not going to move your decimal to the right. Okay. So you're not going to make it big, the gram number bigger. Okay. You're going to move it to the left. 1, 2, 3. You have a 0 here. So your answer is, remember, you're leading 0.037. You might be tempted to round that to 0.04, but you don't want to do that because, as I mentioned, we don't round metric to metric conversions. Okay. Now, if you're sitting there going like, I don't like moving decimals, I feel like I'm going to make a mistake. Great. This is where either your calculator comes into play or dimensional analysis comes into play just to kind of help set this up. So the way I would do this, if I'm doing dimensional analysis, I'm going to take my 37 milligrams. I'm going to make a conversion factor, which we have written here. We're trying to convert to grams, and we want to eliminate milligrams. One of the reasons why I like doing dimensional analysis from a teaching perspective is that way I can show you that I've eliminated the units that we no longer want, and we can progress on and move on to the answer. Then it's just a matter of putting it into your calculator, 37 divided by 1,000, and you're going to get 0.037 grams. Again, that's your answer. Do not round it. Do not round metric to metric conversions. Trust me, I'll give you examples of doing rounding. All right. Those of you that are here, if you have a paper or pencil with you, if you haven't done it already, go ahead and solve for number 2 and just put your answer into the chat. If you are unable to do that, just I'm just going to wait a few minutes just to see if anyone else can do that. And you can send it as a direct message or a private message if you want, if you are, you don't want to show whether you know it or don't know it. And I won't say who said it. So. Okay, so it looks like we're getting consistent answers, which is great. So you should be getting 1.052. And remember, we don't round that, right? We leave it as it is. The reason we leave it as it is because we do not round metric to metric conversions. The other reason is this is just, can you do it? Okay, this has actually nothing to do with nothing directly to do with administering a medication. It's just, do you remember how to do your unit conversions as kind of like a practice? I think if I were setting up like a dosage calc exam, it would pretty much probably just all be patient, there'd be a medication, there'd be something that you're administering, and then solving for it. And then you guys would be ecstatic, because then that would just pretty much be desired or ordered over half or desired over half, depending on how you have learned that equation. And then, or at least, hey, I know that I can't give somebody 2.73 capsules, right? I have to give them a whole capsule. And that's where you kind of differentiate, do I round, do I not round, and things like that. So we'll get into the nuance on that. And then if you're sitting there going like, well, how would I solve something like this? So first of all, you got to remember that 1 milligram is the same thing as 1,000 micrograms. Isn't that nice how they kept it nice and simple? 1,000, 1,000. Typically, when you're doing the metric system, at least the things that we're doing in nursing, it's usually 1,000 is the number to kind of know. And then it's just, did it get bigger or did it get smaller? So here's my decimal. It's getting smaller, right? Because 1 milligram is the same thing as 1,000 micrograms. So that means I'm going to move 3 to the left. 1, 2, 3. And that's where we get the 1.052. And then if you're working this out, if that's your chosen way, take your 1,052 micrograms. I don't want micrograms. I want milligrams. I want to actually get rid of micrograms. So that crosses out. And then you just have to remember what these numbers are. And I've said this over the years. If you've watched any of my previous recordings, I will tell you, these are commonly missed questions. 1, students try to round when they're not supposed to round. 2, they make the numbers too big or too small, depending on the direction that they choose to go, and they get lost. And then 50% of the time they're multiplying by 1,000, and 50% of the time they're dividing by 1,000. I'm trying to give you some structure so that way when you practice this, that you're not guessing which way it goes, you can actually see it. Okay, so practice that. If that's not something you can do, ordered over half for the majority of the test, but when it comes to the conversion questions, sometimes it's helpful to learn the simple one-step dimensional analysis that might be helpful for you if you ever get stuck. All right, so milliliters to ounces. So to tackle this question, we just got to know what that conversion is. So that conversion is 1 ounce is 30 milliliters. Okay. Now, it's my preference to write these this way. If you prefer to write 30 milliliters equals 1 ounce, perfect. I'm not here to tell you to do anything otherwise. Okay. So what I'm going to do is I'm going to do the same setup strategy. I'm going to take my milliliters. I'm going to convert milliliters to ounces using what I know, which is that 1 ounce is 30 milliliters. Now, if I get a decimal answer, because we're going from different units, we're going from metric milliliters to household ounces, I may need to round to the nearest tenth. It doesn't always work out that way, but if it is, then I will round to the nearest tenth. So I'm going to take my calculator, 173 divided by 30, and I'm going to get 5.76 repeating. Okay, so it's a big long number, 5.76 repeating. And what I'm going to then do is, because it's 5.76, and I'm just going to write that down, 5.76 repeating, then this is where I want to go ahead and round. So I'm going to round this number for my test to 5.8. Okay. So if I was doing that conversion and I'm giving an example of where you would round this. The other thing is, if you see on your calculator a whole long list of numbers, your instructors don't want you to write out 6 to infinity. They want you to round it. You just need to know, do you round it to the 10th or to the 100th? And on this test for CCAC, you are going to round to the 10th if it's greater than 1, to the 100th if it's less than 1, with the exceptions. The first exception that we've already talked about is if it's a metric to conversion. The other thing I was going to mention is, in reality, let's say you were making something, you were preparing like a meal or something like that, and this is kind of what it called for, and you converted milliliters to ounces, and you saw you had 5.8 ounces, and you're trying to cook something or prepare something. In reality, you're just going to say 6 ounces, right? You're not going to waste your time with the fraction, the 0.2 fraction of an ounce. And if you've ever poured out that fluid amount, you realize like that's not a whole lot. Like, a little 8-ounce bottle of water is 240 milliliters. So we're talking about a quarter cup here, okay? Or a little bit more than a quarter cup. All I'm trying to do is get you to kind of wrap your head around this and realize that when we're in the math bubble, we kind of just do these math things. In reality, like in a real nursing situation, you may not be able to round to the nearest tenth. You may have to go to the nearest whole number, depending on the situation. All right. And then teaspoons to milliliters. You just need to remember or know that 1 teaspoon, and sometimes that'll be abbreviated TSP, but 1 little t is the same thing as 5 milliliters. So 1 big T is a tablespoon, would be 15 milliliters. And then you're just going to make your conversion 1.25 teaspoons. We don't want teaspoons. We want milliliters. Each teaspoon is 5 milliliters. So we're actually just going to take that number, multiply by 5. So 1.25 times 5 gives me an answer of 6.25 milliliters. Now that seems like a nice, clean and easy number, but if we're taking this test and we're at CCAC and we're in the CCAC bubble, we're in different units, right? We went from household, right, teaspoon, to metric, milliliters. So we need to round that number. Again, I don't make those rules, just letting you know what you should be doing based off of what the blueprint tells you. So your final answer should be 6.3 milliliters. If for some reason you missed that question, and like I said, I doubt you're going to get a question that even ends like that. I'm just trying to give you some scenarios so you're prepared and to practice, and then give you some different numbers. But if in the event that you got a number like that, just know that you can always revert back to the blueprint and you can inquire, and say, professionally, I thought this is what we were supposed to do in this situation. Dr. Rad even said during the tutoring session, this is what you would do in this situation. If there's ever a question, just politely and professionally argue your point, and you might be surprised that you might get a good outcome for that. All right, so I'm gonna leave. I'm just gonna change this here. I'm just going to say, let's say it's 172 pounds. And then go ahead and solve for pounds to kilograms. Use appropriate rounding rules if they apply. And then just type it into the chat once you get it. All right, good. Yeah, so if you're still working through this, or when you see this later on, initially you're going to take the 172 divided by 2.2, so you can set that up however you like, and then you're going to get 78.18 and then it's just going to keep repeating. That 1.8 just keeps repeating. Okay, we're going to round that because we went from pounds to kilograms. We are now into we're going from household to metric. We're going to round this to 78.2 kilograms. Remember, when you're writing your answers, don't forget your units. Make sure you clearly indicate, don't just write a number. Make sure there's a unit associated with that. All right. So I'm going to jump down just a few because you guys, it's already almost 12:30. I have not, and I want to cover and make sure I cover the flow rate questions because this is the first time you're seeing those. So I want to make sure you know how to do those. And then we can come back up and do some of these things that should be a review from the previous semester from 110. So let me go down to our example of a flow rate question. And then as I'm doing that, if you do have a specific question type or question number you want to see worked, you can just type it into the chat. If you're fine with me just kind of, deciding, well, where we go, then that's fine. All right. So our first couple flow rate questions come after question 16. I'm going to kind of jump around a little bit here. Just wanted to see what we had. All right. So I'm actually going to, that's fine. So I'm going to come back to 16. I'm going to go and do 17 first. Just so you can see some of these examples. Actually, I'm going to do 19 first because that's actually the most direct one. It's very straightforward. And I'll show you what I mean in just a moment. All right. So number 19. So first of all, I'm going to change up this number. That way you get a little bit of a different variety. So let's say it's 650 milliliters over, let's say, 4.5 hours. So I like to make things a little bit difficult to kind of start things out. Actually, let's keep it simple. 600 milliliters. And then we'll keep it at, let's just do 2 hours. This way I can kind of keep it simple to kind of start off with, and then I'll show you variations of this question in just a moment. All right. So the thing that I feel that has, at least what I've learned over the past several years reviewing this kind of these kinds of questions with nursing students the first time they're seeing it, is that they get hung up on, what formula do I use? Do I do dimensional analysis? How do I solve these? The biggest thing is, in my opinion, it's very similar to dimensional analysis. It's just that you don't really have much converting to do unless you're converting, volume, which you won't be, or you're converting time, which you might be. And I'll give you examples of that. So, but let's talk about this. When they ask you, what would you set the rate on the infusion pump to in milliliters per hour? They're telling you to solve for milliliters per hour. Milliliters per hour is the standard for flow rate. Flow rate just means the amount of volume over time. Okay. So the volume that we typically deal with in nursing is milliliters and cc's. The other type that you might deal with is drops, which is abbreviated GTT, which we'll go into an example of that in just a moment. So anytime they ask you, what would you set the flow rate to? They're typically asking you, especially if like you're on ATI and they don't ask you specifically or give you the units to solve for, they're asking you for milliliters per hour, volume over time. It's the standard. If the next time you're in a clinical setting, you see someone hooked up to an IV, look at those numbers, look at the IV, look at the units that are being administered. A lot of times you'll see, oh, okay, they set the infusion at, 250 milliliters per hour. It also looks like they have some medication being infused at, it looks like, oh, that looks like it's a couple drops per hour, or drops per minute, or a couple milliliters per hour, but it looks like it's really small, like 1 ml per hour, which would be a very slow rate. but you would get the idea. Oh yeah, because we don't want to be, flooding their system with a medication. We want to kind of titrate it in nice and slow and easy. That's what this is all about. And then what are these things? Like, you may not know what RL stands for. It stands for Ringer's lactate, which is a part of giving somebody blood. But this could also just be normal saline. Okay. Someone got severely dehydrated and they're getting an infusion, and we can't just throw 500 milliliters of normal saline into their body like that moment. You have to titrate it in. Okay. All right. So since I know that I'm looking for milliliters per hour, what I'm going to do is I'm just going to set this up exactly as it says. 600 milliliters, 2 hours. Once I do that, I'm just going to reduce my numbers. So I'm just going to reduce. I'm going to take, use my calculator, 600 divided by 2, or if you could do this in your head, perfect. And then my answer is just 300 milliliters per hour. So the question is, well, when I set my infusion pump to, I'm going to take my milliliters, whatever the volume they give me, the time they give me, and then I'm going to reduce the number. So 600 divided by 2, and then that's where I get my answer of 300. So you can do that and change the numbers. I would say like probably the most common thing is probably like a 500 milliliter normal saline, and it might be over 6 hours. There's different things, or it might be over 1 hour. Okay. Or it could be a bolus thing where it's happening in a matter of minutes. So let's look at an example where there's minutes being used, and that's this. Okay. So this person is going to receive, and I'm going to change this up. I'm going to say 25 minutes, and I'm just going to make this 200 milliliters. This may or may not work, so we'll try and make sure it does. Actually, I'll do 20 minutes. That way I'll know it should work that way. All right. This is another commonly missed question because you don't like doing dimensional analysis, which I think would help you out in this situation. Or B, you just don't know the whole flow rate kind of situation that's going on. Now it tells you to start off with that this is what it wants it to be, but what is it currently? It says 200 milliliters in 20 minutes. So if I'm writing that down, 200 milliliters, 20 minutes. Now I know, and I know that you know how to convert that time, minutes, into hours. I know you know how to do it. You may already have it, and you may already know like, oh, that's the same thing as, whatever. I'm going to show you the way I would set that up using dimensional analysis, because I think knowing how to do this will help you out later on, particularly in later semesters. But all you're doing is converting minutes to hours. And you've probably known this since grade school, that 1 hour is 60 minutes. Okay. Now, all you're going to do is in your calculator, you're going to take that 200, you're going to multiply across the top. So 200 times 60, which gives you 12,000, big number. Keep that in your calculator, divide by 20. And guess what? You're going to set the infusion pump or the tube feeding pump to 600 milliliters per hour. Doesn't that seem extreme? But that will then, just because you're setting the infusion pump to 600 milliliters per hour doesn't mean that it's going to keep running at that rate. I imagine after 20 minutes, you're going to shut it off. Or if you think about it, 200 milliliters is really not a whole lot of liquid. Okay. Remember, I told you 240 milliliters is 1 cup. Okay. So this is less than a cup of Ensure every 20 minutes. It's probably perfectly fine. You're like, oh yeah, I can drink that much. I imagine most of you could drink a liter of something in less than 20 minutes. Okay. A liter of water or whatever. Okay. So I know that, and you know that it can be done. It's just that the number seems so big, and sometimes that makes you think like, oh, did I choose the wrong scenario? You did not. Okay. All right. Now let's get into these drop rate questions. So what a drop rate is, and I have these listed up at the in the beginning of the review packet that I created up with this document. But basically, we're going to take our flow rate, which is usually in milliliters per hour, but it might be cc's per minute. It might be milliliters per minute. So you have some options. Times the drop factor. Now, the drop factor will be given to you, okay? It'll be listed, such as right here. Tells us on the label, that's our drop factor, okay? If it's not listed and they say something like microtubing is 60 drops per milliliter, okay? 60 drops per milliliter, okay? If you see that, you might see that on ATI. Those two things, the flow rate plus the drop factor, is what's going to give me what is called my drop rate. And drop rate is always going to be drops per minute. Drops is abbreviated GTT. I know that looks like GH, but it's GTT. All right, so let's change up our values here. Let's do 125. And let's do 30 minutes. That's fine. Just kind of change it up a little bit. All right. Now, before I change anything up and before I do work through this problem, the first thing you need to know is when it comes to drops, this is another exemption from rounding, or exception, I should say, because you've been taught thus far that when you round, you either round to the nearest tenth. If it's a number greater than 1, if it's a number less than 1, round to the nearest hundredth. But with drops are a lot like capsules. You can't give somebody a partial capsule and you can't give somebody a partial drop. It's either a drop or no drop, okay? So you're going to round to the nearest whole drop. So if you get a number that's like 20.23, 20 drops. If you get a number that's like 24.45 or 24.72, 25 drops. Okay. Now, at least the way I've written a lot of my test questions, you shouldn't even have to worry about that nuance, but I'm letting you know that just in case you see it. Also, just in case I accidentally made that the case in this example here, but we're going to try it out. All right. So 125 milliliters in 30 minutes is our flow rate. So solving for a drop rate, I'm going to start off with just writing out my flow rate. My flow rate, as listed there, is 125 milliliters. And it's flowing at that rate over a time of 30 minutes. Now, instinctually, especially since we just talked about it, you might want to convert minutes to hours to get your milliliters per hour. But I'm going to tell you not to do that. You don't need to do that. The reason you don't need to do that is because what is your final answer in? Final answer, the final units that you're looking for is listed here as GTT per minute. It's drops per minute. So don't convert minutes to hours if you don't need to. Okay. The only time we needed to really convert minutes to hours is if we're looking for milliliters per hour and it gave me minutes as my time. There may also be a situation where you need to convert, especially for doing flow rate questions, where you're going to need to convert hours to minutes. And then you would do that. You would convert hours to minutes. And I have an example of that, and we'll go through that in just a minute. All right. Now, the formula or the flow of this question, or even this is still technically dimensional analysis, I don't want milliliters. I want drops. Do I have a way to convert drops to milliliters? I do. Right here, that number 15, you can see it says 15 drops per milliliter. If you can't see that, that's what it says. That is your drop factor, okay? So I want drops, so I'm going to abbreviate that GTT. I do not want milliliters, so I'm trying to get rid of that. But even if you don't remember that, as long as you remember flow rate times drop factor, and then make sure it's in per minute, then that's how you do these types of problems. All right, so this is going to be 15. This is going to be 1. And then we're going to solve for the equation. So I'm going to take 125 times 15, which gives me 1,875. And I'm going to divide that number by 30. And I'm going to get 62.5. Okay. Now, what did I just say? We cannot give somebody a partial drop. So I have to round that. Okay. So I'm going to round it to 63. Now, in reality, you may only have the choice of 60 or 65 drops per minute for your particular whatever you're administrating. Okay. So the reason I'm saying that is because in reality, you might set this to 60 or 65. It just depends. So yes, go ahead with your question.
I just had a question on like my setup. So how I do the setup is I set it up as because this is the way that works for me. I do 125 milliliters divided by 30 minutes times the drop factor. Is that still okay?
Yeah, and that's essentially what I did. I just wrote the way I wrote the drop factor. I just wrote it as a dimensional analysis. But yes, that is correct. You're doing it right.
Oh, okay. Thank you.
You're welcome. Yeah, and I'll always be the first one to tell you guys like there's no one way. There's I mean there's definitely there's a few right ways and definitely a lot of wrong ways, but as long as you're getting the same answer I'm getting, if you're doing it or setting it up a little bit differently, you're doing it right. So just I'm not here to change anything that you're doing. When I do these types of questions, I don't write anything down. I say, okay, I'm going to take the milliliters over minutes times 15, like you just said, and then go from there. So you're doing that perfectly. Now, in reality, like if I was writing this test the way I probably would have written this as 120 in 30 minutes. That way you got a nice even number instead of the 125. So 120 would have given you an answer of 60 drops per minute, and then we would have been done and over with it. But I at least wanted to show you what this would look like as rounding. I should also say, like, let's say you got an unusual answer for like one of these milliliters per minute or milliliters per hour questions. You are going to still follow rounding rules when it comes to that. So if you get like 10.25 milliliters per hour, you are, at least from based off of the blueprint, you are supposed to round that to 10.3 milliliters per hour, whatever that happens to be. Okay. Let's look at another drop rate question. So I'm going to push this down to the next page. All right. So let me change this up. What's this say? 1,000. And let's just make this. Okay. And maybe I'll make it 6. Try to make it so the numbers are even, but it may not work out anyway. So, okay. That's fine. All right. So now this tells me I have a volume. It says the physician ordered 1,000 cc's of dextrose 5% normal saline to be infused over 6 hours. So that's your flow rate, 1,000 over 6. Your tubing is labeled as below, so your drop factor is 10. Hopefully you can see that is listed here, 10. And I will say, if it doesn't give it to you, you probably can safely assume that it's 60. And they usually will say microtubing. But they should be either giving you that number or there should be a label that you're getting that number from. You can't just guess it. But if they don't give it to you, it's probably 60. Just letting you know, 60. All right. So I'm going to take 1,000. We know it's cc, but you should know that 1 cc is the same thing as 1 ml. So I'm just going to write that here like this. And then I have 6 hours. Now, I can go ahead and just do my next step, convert the drop factor. But the other thing I need to do is I need to make sure that I account for my time. So that 6 hours, I need to make sure I convert that to 60 minutes. Okay, or six times 60. Some students in the past, and even I do this, I'll tell you, like, before you even set this up, 6 times 60, so it's 360 minutes, and then do 1000 over 360 times 10, and then that way it saves you a step. But just in case you don't think in those terms, but all I did was I took 6 times 60, which is 6 hours times 60 minutes. And so my alternative way for setting up this question would be 1000 mil over 360 minutes, and then times my drop factor. I'm just trying to show you the two different ways to do the same thing. Either way, we're going to come up with a number that we're going to have to round. All right, so if I do option 1, 1000 times 10 gives me 10,000 divided by 6 divided by 60, and I'm going to get 27.7 repeating. So I'm going to round that number, because it's a drop, to 28. Same thing here. 10,000 divided by 360. I'm going to get the same answer. So I'm going to get that 27.77 repeating. Okay. And I'm going to round that to the nearest whole drop, because I cannot give a partial drop. Same reason you can't give somebody a partial capsule. Just can't do it. All right, the last flow rate type question here is going to be this one, where it's just like, we know the flow rate, but now we want to know how long it'll be flowing for. How long will it last for? So let's say I have, let's just make this 1250, 1,250 milliliters. Actually, let's change this up, and let's just say it's 1.5 liters. And it's infusing at, let's say, 250 mil per hour. Okay. So the question is, how long will this infusion last? You might be able to do this in your head. You might be able to say, like, oh, okay, so 250 in an hour, 2 hours, it'll be 500, 3 hours, it'll be 750, 4 hours, it'll be 1,000. And you can kind of just count up from there. Or you can just take, so you might need to do a conversion. So hopefully, that 1.5 liters is the same thing as 1,500 milliliters. And you're not going to like the way I'm doing this, but again, this is just the way my mind works as far as dimensional analysis is concerned. It's just my system. But if you're getting the same thing I'm getting, then you're doing it right. I'm going to take what I'm trying to get rid of, which is milliliters, right? And I have 250 milliliters per hour. And then I'm just going to take that 1,500 divided by 250, and that'll tell me 6 hours. Like I said, if you don't like dimensional analysis, you're not going to like the way I do that. And I don't even know if you'll see a question like that, but if you do, just know that you could just count it out and just be like, okay, the shorthand of this is you're going to take the total volume divided by the flow rate. That should give you the time. The other nuance to this type of question is it might say it starts at 8 a.m. When will it finish? You just need to calculate, okay, well, 6 hours from 8 a.m., whatever that time happens to be. And then remember, it'll be p.m. after 6 hours. So, because 4 hours, it'll be noon, and then another 2 hours, it'll be 2 p.m. All right. So those are the kind of the new questions that you're going to see, is these flow rate type questions. We have about 9-10 minutes left. Do you have any questions from the things? previously that you'd like to see work through again. Or if not, you can always, come on to the next session and ask those questions depending on who's attending. But if you have any questions from any of the other question types, let me know. Go ahead.
So I know that if we get a problem that says we have to label the cup or the syringe, there's a certain way we have to do it. Could you go over that one more time?
Sure. So, well, first of all, if there, I don't know if there's a certain way to label your cup. Because I've seen students where they've shaded it in. I've seen students where they just kind of, mark the answer, like they circle it, or they, put a line like at the level. I don't know. And if it's on Blackboard, you're just dropping a point on it. So I don't know specifically for a cup, but for the syringe, if you get a mixing of insulin question, I have another thing that I'll show you here. Just give me one moment. All right, so this example, this is from a textbook that tells you about mixing the insulin syringes. So one of the things, like when you're labeling it, if it asks you to label and draw out your insulin syringe, again, I don't know if they're asking this question still, but if they are, this is how you would label your syringe. You would have the two types, regular insulin, and then whatever other type, usually it's N or Humulin N or NPH. You always draw regular first, okay? Now, because you drew regular first, that means technically the regular insulin is near the plunger side of the syringe. So this little, this is what I'm certain that's what it's called, but this little spot right here where the syringe is, like you can kind of see the little plunger thing here, that part, that's where your regular insulin gets listed. Okay. So when you know that, or at least when you are introduced to that, that at least helps you understand why they're asking you to label this way. In reality, for any of you that have done mixing of insulin, you know that it just all mixes together. There is no, you can't see the separation. The main reason you're pulling regular first is because it's clear. Once you pull the cloudy Humulin N, it all mixes together, but that's why you pull the clear first. That way you're making sure you're getting the appropriate amount. Anyways, saying that, if you're labeling this, you're going to put a mark. It'll tell you to mark the syringe or mark the syringe. You're going to mark at the 10 units, which is going to be the total minus 10. So 30 units plus 10 units is 40 units. You're going to do 10 minus, 40 minus 10, which happens to be the same number for whatever your Humulin N is. And that's usually how it works. And then the remainder of the syringe is your non-regular insulin. Okay. So this is how they want you to label that. So saying all that, let me go back to the practice set and show you how to do that and how to answer the question, at least how it's listed on the practice set, just in case you see it. All right. So let's say we get a insulin unit set up here. So I'm actually going to change this here. So let's get rid of that. I'm going to change the numbers here just so we have something different. And I'll show you how I would answer this, and then you can get this straightened out. So let's say this was, let's just make this 20 and make this 60. That's fine. Okay. So the first thing is, it says the first thing you need to make sure you do is, and this is what you saw in the 110 test, is to select the correct syringe. And I think that was the only question you had, is which syringe would you use? You need to know that when you're dealing with insulin, that you always choose the syringe marked in units. because that's how it's administered. Okay, so there's no, even though on the insulin package, and I think it's even down, oh, it's not on here. Even on the insulin package, it does tell you like what one, like a unit is so many milliliters. It does tell you that, but that's not the syringe you choose when you're dealing with insulin. So anytime, anytime we're dealing with insulin, it's usually you're going to be choosing syringe B if it's this graphic, because you're choosing the one that has units associated with it. Okay, so select the correct syringe would be syringe B. Then it says solution and amount to be drawn up first. So you need to denote that, and I would even just write that you're going to draw up regular first. Okay, and the amount to be drawn up first is going to be 20 units. Now, you don't write that on the syringe. Basically, you want to look at the syringe as if it's in its final state. Okay, it's all the insulin is in the syringe at the end of the question, basically. And then it says correct total medication. So the correct total is 20 plus 60, so 80 units is total. Now they tell you to do 2 arrows, but I'm going to show you how I would mark this based off of the textbook. I would first make sure I have a mark at 80, indicating that is the total amount. This is total. I would then have another mark at 60, and then I would indicate that in between the total amount and 60 is where your regular insulin is. And then the total amount between your the total amount between 0 and 60 is where the N is located. So in reality, I'm probably going to have 3 marks. But if you want to correctly answer this question, this is how I would answer that. If you get a question where it tells you to like mark the syringe and fill it in, like a TubeX question, like here, then you're just going to put a mark, wherever that happens to be. Okay, so if that's here, you put that mark here. Sometimes they ask you to shade it in to the amount. If you need to, just do your best to shade it in. I'm obviously doing this with, a digital pen. So it just depends on if you have a paper test or if you have a non-paper test. So I would just verify with your instructor how they want you to label that, filling it in wise, and then go from there. So, all right. So that's going to complete our 130 review. Like I said, I'm recording these. I will upload them. And then I will be back for 130 at 3:45. So if you have any questions between now and then, just reach out to me and let me know. Or if you have other questions, just let me know during that review. And I hope you got something out of this review. And I will have these posted most likely by either the end of the day today or tomorrow. And if I don't hear from you, good luck on your 130 test. Yep, you're welcome.